Okay, I think we can start now. I hope everyone can hear clearly. So today, so this month's session will be on data description. As usual, you can download the slide or ask anything in Google Classroom. Resources and links will be posted there as well. And the code will be displayed at the bottom of the bottom corner on every slide. So if you guys have any question or have any problem, you can use the chat function, or you can unmute yourself and ask something. Because by default, everyone will be muted. Okay, so the outline of the today's discussion is as shown. Today will be very brief. Basically, we will touch on the types of data, followed by basic ways to present your data in figure form. There will be more example of data presentation in the future topics if we have the chance. But for today, we will only look at the simple and basic charts. So in general, a variable can be classified as independent variables and dependent variables. Independent variables are usually the predictor variables, while dependent variables are usually the response variables. So we will look at a few examples later. Once you have identified your main variables, you can use statistics to explain the phenomena or observation that you have gathered in numerical form. Even though your data is non-numerical, for example, expression of statements, or you may, or something like gender, so you may categorize them into a specific group and recode this data into numerical form prior to analysis. So now we're going to look at the types of data. Like I mentioned just now, your study should typically have independent and dependent variables. First example is a study where a researcher wants to explore the difference between Paeds cardio patient versus other patients in relation to stress test, for example. So you may suggest that the independent variables, also known as predictor variables, such as physical condition, age, and mental state, would be among the good predictors for patients to predict the patient's response to stress tests. So the second study, for example, a researcher may want to look at whether diet, lifestyle, and dosage of hypertensive drug could alter blood pressure or hypertensive patient, for example. And the third example would be a study that explore the variables of mother's age, BMI, and diet, and their relationship towards the birth weight of the child. So for those who are yet to have a proposal or in the midst of preparing your proposal, you should identify this variable so that you would have an impactful and sensible objective for your study. And it will be a much clearer experience later on when you have already identified your dependent and independent variable earlier. And for those who have done your proposal, you can try to recall your independent and dependent variables from your objective. So that you have a better picture of what you intend to study. Yeah, so basically, to summarize this, independent variable is usually the variables that you want to study, and the dependent variable is the final outcome, the respondent variable. So next, data data classification is we can categorize them whether they are quantitative or qualitative. So quantitative data just simply means numerical data, whereas qualitative is typically categorical data. Numerical data can be discrete data, which what it means is actually round numbers. So for example, frequency of fever, or number of siblings, or any other counts that is round numbers. So continuous data is something like height, weight, level of C-reactive protein, for example. So they can still have round numbers, but the distribution is usually wider compared to discrete data. So that's the main difference. We can class them into nominal scale, ordinal scale for qualitative data, but we're going to talk about this later. So more on quantitative data. So more example here. So continuous data is usually measured data. For example, blood pressure, weight, blood glucose. So that's why we call it continuous, because it can have a very wide range. So for discrete data, on the other hand, is typically a data count. For example, number of admission, number of asthma attacks. Okay, so next for qualitative data, two main groups are nominal and ordinal data. So nominal scale is basically when you have, when you want to present your data into code. So for example, 1 for male, 2 for female, or 1 for patient, 0 for control, and so on. For ordinal scale is when your number holds some weightage or implying a rank. So for example, cancer stages. You want to put as, for example, stage 1 cancer as number 1, stage 2 cancer as number 2, and stage 3 cancer you code it as 3, and so on. It can also be like, for example, response for a questionnaire, the answers of the questionnaire. For example, disagree, agree, or neither. So it would have some sort of rank there. So you would put them in ordinal scales. So this is very important, especially when you building your database in SPSS, for example, so that later when you want to do a more sophisticated analysis, for example, regression analysis, for example, a binary logistic regression. So you may want to code your data much earlier, so that later on when you want to do this, you can straight away do without the need to like recode everything again from the beginning. So next, we're going to look at the basic data presentation. So we're going to briefly look at simple frequency polygon, class interval polygon, pie chart, bar chart, and histogram. These are all very basic data presentation strategy that usually people will do. Of course, there will be more advanced graph or figures that you can do, but this is the basic first. So first example, let's say your data contains a number of times of young mothers visit to the clinics for postnatal treatment 2 weeks after delivery. So you may have something like this, like name Azlina visits 1, Bhavani 3 visits, Chan 5 visits, and so on. So this is considered as raw data. So you may want to report this as things like this. So from the raw data, you can report a study as frequency of visits using simple polygon chart, or also called as line chart. So typically on the left is what you would report in table form. So you have the you can see from the table form like the 1 visit and 3 visit is the most frequency that the mothers come in for. So from this data, if you report it in the form of line polygon, for example, the readers may be able to see and interpret your data quicker at a glance. So I did this graph using Microsoft Office, but of course you can do directly in SPSS as well. There are also other software that can do more sophisticated, more customizable graph and figures, for example, GraphPad. But of course, this is also a paid software. But I think Excel and SPSS is sufficient for normal type of data. So next example is that you have a list of birth weight of, let's say, 35 infants. So like this one. So this is a type of numerical and continuous data, of course. But if you feel like it would be a loss of information, if you just report a median, for example, then you may want to report this data into interval groups. So basically, you group them into some interval class or interval groups. So you may put them in group based on current guideline or even literature. So for example, let's say you have a BMI. There will be a BMI classification for Asian, for example. Then you may use that guideline. Or you have something novel. You may use your own judgment. For example, use quartiles to get 4 groups. So basically, you calculate so from your data distribution, you calculate the quartile, and then for example, you use SPSS, and it will give you Q1, Q2, Q3, and Q4. Then you can use this as your class interval. And second example, probably you want to have just 2 groups. So probably you can make a cutoff at mean or median. So you can have a bottom half and top half group. So this is the ways for you to get the class interval. So once you have decided on the class intervals, you may plot a line graph to better present your data. So here the readers will be able to see the distribution of data as well, rather than just a single value of mean or median. So of course you have the option if you feel that your data is enough for you to report just the median or mean, then it's fine. But if you somehow your study is about showing or considering the distribution of data, or you want to highlight like basically the pattern of your data, then you may want to consider to use to report in graph form. So of course it is not always necessary, and it usually depends on its usefulness if you present data like this. But most of the time, median and mean is fine, just that if you want to show the distribution. So next, you can also report. So using the same data, you can also report your data in the form of histogram. For my opinion, is just different a little bit in terms of visually, but the interpretation and the information that you can get from histogram or the line graph is about the same. So last but not least, I think is simple pie chart and bar chart. So for example, we use the data of the young mother visit earlier. You have the option to report in pie chart or bar chart form as well to show the distribution much clearer. So it is up to your liking for the selection. Typically, for pie chart, you must have 3 or more groups, because if you have just 2, it will not be accurate. So it usually will use 3 or more groups for pie chart, but for bar chart, it's fine to have just 2. Yeah, this is probably the last one. So we have side by side and stack bar chart here. So this is a variation of the bar chart earlier, but with the advantage of being able to report a comparison. So consider this data where you have a bivariate categorical data, let's say smoker versus non-smoker, and you want to explore the relationship between the variables of lung cancer risk, for example. So of course, from the table, you can see that more people who have low risk of lung cancer are non-smokers. So you can have the same interpretation from the table, but it will be much clearer and neater if you present using the side-by-side bar chart or stack bar chart, so that immediate comparison can be made by the readers. So side-by-side chart on the left, for example, we focus on reporting the actual numbers. So you can see on the y-axis is actually the numbers that you have, whereas stack bar chart on the right is focusing on reporting the proportion of percentages. So it's up to you. Both will have the same impact, which is to make your readers to let your readers compare your data much quicker and easier. But it's up to you to choose whether you want to report in terms of the actual numbers or the proportion or the percentage of the data. Of course, for the stack chart, even though you report in the form of proportion, you can still put on the bar chart, on the stack bar chart, the actual numbers. So you have the option there. So that's all for today. It's a very brief one. I can show quickly how to do a graph. It will not be extensive one. I try to see whether I have some data here. Hold on for a second. So here you can see this. Okay, so you can't really see this because it's a Mac, so you can see. Wait, let me try again. Okay, I hope you can see everything now. So basically, let's say you have a data like this. Yeah, something like this. So you can press the graph and then chart builder. So it's okay. Then you can select. This is XPSS, so you can select the type of bar chart or line chart or scatter or dot or pie chart that you want. So let's say we try this one, pie chart. So you can put in, for example, ethnicity. So it's sliced by ethnicity, for example, and then right, okay. Oh yeah, this one is not so good example. Yeah, so I don't have a good example of data here, but you get what I mean. So you can try to play around with your data. So basically, you can set the type of graph that you want. So this is a stack chart, for example, and then box plots. You can try to play around. And you have any question, then we can meet and I can help. So I think that's about it for today's session. Hopefully you learn something. So if you have any question, you can email me, or if you want to have some consultation session, you can as well just email me. So I think that's all, and thank you. You can unmute yourself if you want to ask something.
I'm good, Shafiq. Thanks, Shafiq.
Yes. Thank you.